Hey, welcome back. It's been a few weeks since we did an update on our home automation project and it's come on a long way. In this video, we're going to talk about some of the challenges we've faced, show you a proof of concept for actuation based on recorded data. We're going to graph some of the data, and we have 2 new sensors, as well as looking at other applications for this sort of technology.
Let's start by getting the challenge out of the way. Firstly, we continue to have Wi-Fi issues on the ESP sensor unit, so we wrote a little script to test Wi-Fi signal strength, which involved us wandering around the house with a breadboard full of LEDs. This data was also logged back to the server. If you want to see that in detail, there's going to be a whole nother video dedicated to getting that little thing up and running, and you can pull the code from our GitHub.
The second big challenge we faced was getting the server and the sensor unit, which is what we're calling this little thing, to reconnect after we turn the PC off, because we don't tend to leave the PC running overnight, and we spent a fair number of hours trying to get this to work. We think the main issue was that when we shut down the PC, it would disconnect the socket and then it wouldn't reconnect without us having to restart the code on the sensor unit. We did try to create a reconnect function on the ESP, but it didn't work consistently. We tried a few fixes for this, but we haven't yet found a way to get this running just with the PC, so we switched our server over to a Raspberry Pi, which is constantly running on the board behind us and displaying data on this screen. If you'd like us to solve the issue on the PC, let us know and we can continue to work on that. If you don't have a Raspberry Pi but you want to try this at home, you can also run this from an old laptop. It doesn't need to be high spec, it basically just needs to be able to connect to Wi-Fi.
Our third major issue was that trying to log data over long periods of time, which generally takes a long period of time. Logging lots of data quickly doesn't let us know if it's going to be working in the long run. At one point we had data consistently recording to the PC for roughly 4 hours, but once we returned it had crashed. We had the same thing after 4 or 5 days of data on the Raspberry Pi, but now it seems to be getting consistent data points.
Finally, we haven't really worked out how to log errors properly. We did have some error logging to a text file on the ESP, but it mostly just told us that there were errors and not why there were errors. It mostly spat out econ aborted, which tells us that the network dropped, but doesn't tell us why.
But with all that out of the way, we still had some fun and made some good progress. Once we had the LED array showing the Wi-Fi signal strength, we set it up to send data every minute about its Wi-Fi strength, which printed to the terminal on the Raspberry Pi. We did this mostly to make sure that neither unit went to sleep and that the socket was still active between both the Raspberry Pi and the ESP. Only every 15 minutes would it send data about the temperature and humidity in the room, and it was this data that was actually logged. We are letting it run like this with the sensor unit in the living room, and so far have just under 10 days of good data. Let's start with talking about the actuators and what that really means.
Insert actuators here.
So here we are with our actuator board. We've got 2 of these little relays. This one sort of as it comes in the Arduino kit, but with some soldered legs on the bottom to make it able to go into the breadboard, and this one is with the breakout board, so you can buy these on breakout boards, and these are much easier to use, much sort of simpler. So this is set up entirely analog. There's no microcontroller in here at the moment. Each relay has an off position output, and that output is still hot or still live. So at the moment they're both in their off positions, and we have this LED lit here and this one lit here. I'll just turn that sideways so you can kind of see them a bit better. For the small relay as it comes in the Arduino box, this is our signal cable, and if we just put that so that it's powered, the signal cable is powered, it will switch to the on position for the relay, and that switches the light. And so that's what you would pull up with a digital pin. Pull that up with your output on the Arduino or on the ESP board or anything else, and that would basically switch the relay. And then we have the same here. This one has another little light to say that it's switched. It took me a little while to work out with this, but essentially the relays always have power going through them. It's only when you switch it that that power is diverted. So the way to resolve that would be to unplug, let's say, the off position. So now this tail is hot, there's still power running through it, but as long as that's not connected to anything, we have no actuation. And then when we switch our signal line, we turn on our load. And there'll be a little breakout video, a couple of minutes, just explaining these and how to actually wire them up, because it can be quite complicated. But yeah, this is ready, so we'll probably use this to start with for our actuation, and we'll wire this up to something with mains voltage to sort of get a good idea of how everything actually works.
And now we can talk about the data. Since we are now running it on a Raspberry Pi, the first thing to do was write a little script to retrieve the data from the Pi to the PC. The main process is, so here we're configuring the sockets. Here we've got the receiving and saving file names. We're then connecting the sockets together. And here we are sending the file name to the Raspberry Pi, and we're waiting for a response for how many data lines are in that file. And then we're receiving each line by line, from the Raspberry Pi. And that will save to the file that we told it to. So if I quickly just run this file, we see that we're expecting 32 lines of code, and we've just received all 32 lines of code. And now this is the server side, and here is the file code. So we're configuring the sockets and we're connecting them to each other. We are receiving the file name that the Raspberry Pi needs to send over. We are then reading how many lines are in that file, and we're sending the amount of lines to the computer, of which we then wait a short while and we start sending all of the lines one at a time, and then we close the socket. Seeing as we were running this in the background, whilst the Raspberry Pi was still receiving actual data from the sensor, we made a copy of the data file before requesting the data. I will say the data will look wrong, and that there is actually probably some outliers, but most of it is actually correct, and the house is just really cold. But it's pretty basic for now. We have a graph with temperature over time and humidity over time. It's not exactly exciting, but with the potential for actuators and further monitoring, I think it's obvious there are plenty of good opportunities ahead.
Graph, do this.
Graph.
And then we can talk a bit about sensors. I've been looking into sensors a fair amount, and it seems most air quality sensors don't give you data about individual gases or pollutants. They tend to record a bunch of different values within a black box and then spit out an overall value for air quality, which isn't really what we want to know, and generally feels like we can't really tell what that's doing, if it's doing anything at all. But we have found the MQ2 and the MQ135. The MQ2 is tuned to detect flammable gases like LPG, propane, hydrogen, and isn't that useful for us in this instance. But the MQ135 looks for ammonia, carbon dioxide and smoke. If it's picking up smoke, we've probably got bigger problems, and it's unlikely to be picking up ammonia, so we can assume that its value correlates with carbon dioxide, and that is one of the things I would like to track. We've managed to get them wired up, but we're still playing with that, so we'll talk about them more in the next video on this project. Now that we have the bones of a system running, we can talk about potential applications for this, as there are quite a few that might be interesting. The first and most obvious one is simply the air quality, temperature and humidity in your house. Whilst the temperature aspect of this is basically just a thermostat, adding humidity would be helpful for bathrooms and kitchens. There have also been a number of papers published about how carbon dioxide levels affects the attention of children in school, and so having that information in a home office environment might also be interesting to see if it correlates with adults working from home. Another way to apply this tech is in greenhouses, where humidity and carbon dioxide might actually be really important for optimizing plant growth. I'm pretty fascinated with hydroponics and vapoponics, and for vapoponics you'd want very high humidity and quite high temperatures to stimulate growth. The third application that I'm also quite interested in is having a small temperature controlled cupboard where I can set it to maintain 22 degrees to optimize fermentation for home brewing, as that's something I do a fair amount of, and I think some of my yeasts get affected by large temperature fluctuations in the living room. Anyways, that's all for today. We've covered the problems we faced, testing Wi-Fi on ESPs, and how we can add actuation, pulling and visualizing data, scope for further expansion, and other applications. That feels like good going alongside a full-time uni course and working. Anything you want to add? I think you've covered it. At the moment we alternate between two projects. We do fortnightly sort of week on, week off, or fortnight on, fortnight off between, at the moment, this project and the gantry robot. And that's been somewhat challenging, and it feels like we're making quite slow progress. The next main project upload will be about the gantry robot, and then we will finish off on this project. And after that we intend to focus on one project at a time to keep everything a bit more coherent. We're still experimenting and working out what's best. We're also using new recording equipment for this one, so let us know if you can tell the difference. Thanks for watching, and we'll catch you soon. Bye for now.